So, ang i-discuss natin for today ay ang simplex method of solving problem. To simplify yung method natin for simplex, ginagamit yung simplex method sa more than 2 variables. Unlike sa graphical method, ginagamit lang yun para sa dalawang variables. Para ma-solve natin siya ng maayos, may susunod lang tayong rules. The development of the simplex method computation is facilitated by imposing requirements on the LP constraints. So we have two requirements. The number one is all the constraints are equations with non-negative right-hand sides. Ito yung RHS. Number two is all the variables are non-negative. Then converting inequalities into equation with non-negative right-hand sides. So, yung RHS natin o right-hand sides, nagre-represent siya the availability of resources. Yung left-hand side naman, nagre-represent siya the usage of the resources by all the model activities. The excess amount of the RHS over the left-hand side then yields the unused amount of the resources. Ano nga ba yung unused? Dahil sa RHS, pwede magkaroon ng unused sa left-hand side, which is yung mga ating unused, ito yung tinatawag na slack variable. Kung saan yung ating slack variable, siya yung pupuno para mag-equal yung ating left-hand side sa right-hand side. So, ito yung example natin. Para mabuo yung 50 na yan, kailangan ng slack variable. So, ito yung mga ating objective function and our constraints. We have 3 constraints. Number 1 is mixing, bottling, and packing. Convert inequality equation constraints into equality and set up variables. So, magkakaroon tayo ng example 1, ito yung men's shampoo, example 2 for women's shampoo, and magkakaroon tayo ng panibagong variable which is S1, ito yung slack 1 or unused minutes of constraints 1, slack 2 or unused minutes of constraints 2, slack T or unused minutes of constraints 3. Set up the objective function where 0 is the assigned profit per unit of slack variable. So, kung saan ito yung ating objective function, magkakaroon ng 0S1 plus 0S2 plus 0S3. Okay? So, convert naman natin yung constraints to equality with slack 1. Like I said kanina, yung ating constraints ay magkakaroon ng slack or unused para mag-equal o mabuo ang RHS, which is yung 100, yung 84, and 90. Ito naman yung exam 1, exam 2, S1, S2, S3 is equal to 0. Next, we write the objective equation as max z is equal to 6 exam 1 plus 8 exam 2. So, ililipat lang natin siya like this. Z minus 6 exam 1 minus 8 exam 2 is equal to 0. The next one is create na tayo ng tableau. As you can see is nare-rate na natin yung objective function and constraints. So, ngayon, gagawa na tayo ng table. Ang nilalaman ng table natin is yung basic value and expected variables, which is x1, xm1, xm2, s1, s2, s3, and RHS. Ililipat lang natin yung objective function and constraints dito sa table na to. Saan is yung z is negative 6, negative 8, and 0, 0, 0, 0. Ayan. Next one is S1 is 5, 10, 1, 0, 0, 100. Next one, S2 is 7, 7, 0, 1, 0, 84. Yung S3 naman is 9, 5, 0, 0, 1, and 90. Ayan. After natin malagay yung value or objective function and constraints sa table, ay may gagawin pa tayo. At ito yung Gauss-Jordan row operation. It is identifies the entering variable column as the pivot column and the leaving variable as the pivot row. Magkakaroon tayo ng entering value and leaving value, kung saan yung intersection ng ating pivot column and pivot row ay tinatawag na pivot element. So, paano ba natin malalaman kung ano ang pipiliin nating pivot column and pivot row? Using simplex optimality condition, select the most negative coefficient in the objective equation entering value. So, dito lang kayo titingin sa may objective function. The most negative coefficient. So, ito yon. Ito yung sa exam 2. Ayan. Ayan yung the most negative coefficient. Ngayon, the next one naman is hahanapin natin yung leaving variable. Saan i-compute natin yung ratio ng right hand side natin doon sa napiling pivot column or entering variable. So, gagawin natin yung 100 i-divide natin sa 10. So, 100 divided by sa 10 equals to 10. And 84 divided by 7 is equal to 12. And 90 is divided by 5 is equal to 18. Ayan. Nakuha na natin yung ratio niya. So, ang sabi dito, dapat daw ay minimum positive ratio. So, ang minimum positive ratio natin is number yung 10. So, ang magiging pivot row natin or yung leaving variable is ito. Itong slack 1. Ayan na yung magiging leaving variable natin. After po nating makapili po ng pivot row, at the same time, meron na rin po tayong pivot column. Yung intersection po ng pivot column and pivot row is, ayun po yung pivot element. Ayan po. Replace the leaving variable in the basic column with the entering variable. Yung S1 po, ito na po yung magiging leaving variable at yung exam1 is magiging entering variable. Mapapalitan po siya nito dito. So, yung S1 mapapalitan po ng except po. For the new pivot row po, meron po tayong equation dyan is current pivot is divided by 2 pivot element. Yung current pivot po is i-divide nyo po dito sa element. Isa po yan po yung pivot row po. Ito po yung current pivot. Sabay i-divide nyo po dito yan. So, after po nun, mag-create po tayo ng bagong table para makuha po yung new pivot row. Para makuha po yung yung new pivot row is i-divide yung current pivot row sa pivot element. Which yung 10 po yung element po natin, diba? Yung pivot element. Mangyayari po is 5 divided by 10 is equal to 1 half. 10 divided by 10 is equal to 1. 1 divided by 10 is equal to 1/10. 0 divided by 10, 0. 0 divided by 10, 0. And 100 divided by 10 is 10. Ayan po yung new pivot row. So naman po, ang isasolve po natin is say, ang equation niya po is current row is minus pivot column coefficient times new pivot row. So magiging ganito po siya. Ano po yung current row po kanina is, diba, sa Z is -6. Yan. So negative 6. So minus 8 minus negative 8 times 1/2. Ito po yung new pivot row po, which is ito po yun. Ito po yung new pivot row. Ito times yun po yun doon. Then ang mangyayari po is negative 6 minus negative 8 times 1/2 is equal to negative 2. Yan po yung sagot, negative 2. Ngayon, next naman po is negative 8 minus negative 8 times 1 po is equal to 0. Yan. Lagi pong 0 yan. The next one naman po is sa slot 1 po is 0. Minus negative 8 times 1/10 is equal to 5. Yan po yung sagot, 5. Sa S2 naman, 0 is minus negative 8 times 0 is equal to 0. Po. S3 naman, 0, ganun din po, minus negative 8 times 0 is equal to 0. Sa RHS naman po, ganito, 0 minus negative 8 times 10 is equals to 80. Ayan po, yan na po yung RHS nya. So ang isasolve naman natin is yung S2. Yung current niya kanina, diba, is 7 minus 7 times 1/2 is equal to 7, 2. So ang sagot sa S2 is 7, 2. Next one naman is exam 2 is 7 minus 7 times 1 is equal to 0. 0 naman to. Ayan. The next one naman is S1 is 0 minus 7 times 1, 10 is equal to negative 7, 10. Negative 7, 10. Next naman is 1 minus 7 times 0 is equal to 1. And sagot dito is 1. The next one is 0 minus 7 times 0 is equal to 0. So, 0 dito sa may S3. RHS naman is 84 minus 7 times 10 is equal to 14. Ayan. Ayan, tama sagot po. So, ang next naman po isosolve natin is yung S3. Ganun po ulit. 9 minus 5 times 1/2 is equal to 13, 2. Sagot dito is 13, 2. Next one is 5 minus 5 times 1 is equal to 0. Ito, 0. And the next one is 0 minus 5 times 1/2, 10 pala, is equal to negative 1/2. Next one, ang sagot dito sa S1 is negative 1/2. The next one is 0 minus 5 times 0 is equal to 0. 0. Ang S3 naman, 1 minus 5 times 0 is equal to 1. 1 naman yan. Ang RHS naman, 90 minus 5 times 10 times na. So, equal to 40. So, 40 dito. Yan po ang S3. So, after po natin makuha lahat, gawin po ulit po natin yung ginawa natin kanina. Yung hanapin po yung the most negative coefficient po. So, the most negative coefficient is itong negative 2. So, ayan. So, ganun ulit. Hahanapin ulit natin yung ratio ng RHS. Divide. I-divide natin yung 10 sa 1/2. 10 divided by 1/2 is equal to 20. 14 divided by 2, 7. 2 is equal 4. And 40 divided by 13, 2 over is equal to 18 over 13. Ayan. So, ang pinakamababa na positive ratio is 4. Ayan. Nakuha na natin yung pinaka mababang positive ratio. So, isolve naman po natin x ng 1 ulit. Ganun lang ulit. 7 over 2 divided by 7, 2 is equal to 1. 0 divided by 7, 2 is equal to 0. Negative 7 over 10 divided by 7 over 2 is equal to negative 1/5. And 1 is 1 divided by 7.7 over 2 is equal to 2 over 7. 0 and 14 divided by 7 over 2 is equal to 4. Ayan, nakuha na po natin. So, ngayon naman, solve naman natin yung z, and yung dati niya is 2. Ayan, 2 minus negative 2 times 1/2 is equal to 0. 0 dito. 4, 5 minus negative 2 times 7, 10 is equal to 2, 5. 4, 7 dito. Kasi 0 divided by minus negative 2 times 1 is equal to 4, 7. S3 is 0 and RHS is 88. Yan. Ayan na po sa Z. So ngayon naman is exam 2 naman ang ating isosolve. Automatic 0 na dito. Next one is 1 1/5 negative 1 over 7 0 and 8. Ganun lang po. So the next one is S3. Computing natin. Automatic 0 na dito. The next one is 13/2 0 minus 13/2 times 0 is equal to 0. Negative 1/2 minus 13 over 2 times negative 1/5 is equal to 4 over 5. Next one is 0 minus 13/2 times 2, 7 is equal to negative 13/7. The next one is S3. 1 minus 13 over 2 times 0 is equal to 1. The next one sa RHS naman, 40 minus 13 over 2 times 4 is equal to 14. So, ayan po ang S3. So, next is babalik tayo sa umpisa. Aalamin yung pivot column. Sabi, sa pagpili ng pivot column, dapat is most negative. So, this time, wala na tayong nakikitang negative sa ating objective function. Meaning, pag wala ng negative, stop na tayo sa paggawa ng table or tableau. So, kukunin na natin yung value ng RHS, which is right hand side. At gagawin natin, ikakopy natin to at magiging ganito. Meaning, yung ating Z, ang maximum profit is 88. At kailangan daw natin mag-produce na 8 cases ng exam 2 and 4 cases ng exam 1 with unused minutes, which is yung S3 yun. So, meaning, yung ating S3 is unused packing. Meron tayong di nasulit na oras sa S3. Kung ito transfer naman natin yung value ng X1 and X2 sa ating mga constraints, magiging ganito siya. So, makikita nyo, 5 times 4 plus 10 times 8 is equal to 100. 7 times 4 plus 7 times 8 is equal to 84. And sa 9 times 4 plus 5 times 8 is equal to 90. So, makikita nyo, hindi sila equal. So, ng left hand side. So, ang gagawin natin, 36 plus 40 is equal to 76. So, nakikita nyo, diba? Hindi siya equal. Gagawin natin, 76 plus natin sa 14, magiging is equal to 90. Ayun yung purpose po ng S3 kung saan siya po yung magpupuno doon sa left hand side para mag-equal sa right hand side. So, ayan na po siya. Therefore, ang magiging conclusion natin for this problem is Gina should produce 4 cases of men's shampoo per day and 8 cases women's shampoo per day to maximize the profit to 88 pesos with 14 minutes of unused packing capacity.
Hello everyone, my name is Siegfried Samson and here we are going to solve this minimization linear programming using the simplex tableau structure. One of the solution approaches in solving the minimization problem is to choose the largest negative value on the Cj minus Zj row to enter the basis rather than the largest positive as done in maximization problems. Another way is to change this Cj minus Zj to Zj minus Cj. And another way is to convert the minimization problem to a maximization problem by multiplying the objective function by -1. So, we will be working with this maximization objective and the constraints will remain the same. The idea is that making cost as small as possible is equivalent to making profit as large as possible. To put this into blue form, we need the right side of all the constraints to be positive. Therefore, we multiply the second constraint by -1 to make its right hand positive. And that also changes the direction of the inequality from a less than to a greater than. The original minimization problem is now equivalent to this maximization one. Writing it in standard form, we introduce a slack variable to the first constraint because it's less or equal constraint. We introduce a surplus variable to the second constraint since it's a greater or equal constraint. And the third one does not need slack or surplus because it already has equality. Based on this model, suppose we make x1, x2, and x3 non-basis by setting them to zeros. Next is, suppose we will have s1 is equals to 18 and s2 is equals to -14, which poses two problems. First problem is that s2 violates non-negativity, and second, there is non-variable representing the equality constraint. Their issues prevent us from setting up the initial simplex tableau. To circumvent them, we introduce what we call artificial variables, sometimes denoted by lowercase and sometimes by the uppercase. In other words, we introduce artificial variables whenever we have greater or equal constraint. Artificial variables are indeed artificial because they have no real meaning in the problem. They are essentially used to set up the initial simplex tableau with a basic feasible solution, and they must be eliminated before we reach an optimal solution. So the equation, as we can see here, for the first constraint stays as is. No artificial required there. We introduce an artificial variable a2 to constraint a2. equation because it's a greater than or equal than constraint. And we introduce another artificial variable a3 to constraint 3 since it's an equality constraint. We denote them a2 and a3 here to match the constraint number. You may prefer them a2 and a3 here to match the constraint and to indicate that the first and second artificial variables are introduced. Since we don't want the model to keep the artificial variables in the solution, we include them in the objective function with a very large negative coefficient or large cost, which we denoted to negative m. Now, m is the largest positive number. You can hold a large number in like 1 billion and all variables are non-negative. Now, the problem is now in tableau form. We begin setting up the tableau with the objective coefficients, followed by the coefficients in the constraints, then the right-hand signs that call them B column. The basic variables will be the ones with the unit column. The ones that have a coefficient of 1 in one of the rows, while the coefficients of the other basic variables are 0 on the row. So, S1, A2, and A3 will be our initial basic variables. And we list their objective coefficients in the CB column there. Now, the ZJ values are calculated by taking the sum products of the column and each of the other columns. For the x1 column, we have 0 times 2 plus negative m times negative 1 plus negative m times 3, which gives m negative 3m or negative 2m. For the rest of the columns, because of the 0 here, we can ignore the first row. And because the two coefficients are the same, we can simply add the bottom two coefficients and then multiply the sum by negative m. So, 1 plus 2 is equals to 3 times negative m gives negative 3m. Then, negative 4m, 0, positive m, negative m, and negative m. For the B column, negative 14m, negative 26m gives negative 4m. For the CJ minus ZJ row, or what we call the net evaluation row, we take the objective coefficient row and minus the ZJ row. So, 6 minus times negative 2m gives 6 plus 2m. Next is negative 7 times negative 3m is equals to negative 7 plus 3m. Next is negative 4 plus 4m and 0, negative m, 0, and 0. We reach the optimal solution when there are no more positive values on this row. Now, this setup is called the initial simplex tableau. The large positive entry on this net evaluation row determines the new variable entering the basis. So, thank you very much for listening. I hope you understand, and you can ask questions about whether you have a important things to know and to clarify. And thank you.